Hello guys, and welcome to our second video in physics. The name of our lesson is Where and When. The focus question for today: what are some different ways of describing and representing motion? We have two ways of describing and representing motion. The first one by using coordinate systems, and the second one by using the physics laws. In the beginning, we will know how to figure out describing and representing motion by the coordinate systems. The new vocabulary that we will learn for today: coordinate system, origin, position, magnitude, vector, scalar, distance, time interval, displacement, and resultant. As we said in the beginning, we will learn what is coordinate systems mean. So in the beginning, we will put a definition for a coordinate system. A coordinate system tells you the location of the 0 point of the variable you are studying and the direction in which the values of the variable increase. This is the definition of a coordinate system. The second definition that we have for today: the origin. The origin is the point at which both variables have the value 0. The origin is the point at which both variables have the value 0. Consider a runner on this coordinate system. Let's suppose that we have a coordinate system here, and we have a runner. The runner started from the 0 point until she reached to 30 meters. So the 0 point here, we can call it, or we can name it as the origin. So she started from the origin until she reached to this point, which is 30 meters. You can indicate how far away an object is from the origin at a particular time by drawing an arrow from the origin to the object. So we can indicate how far away an object is from the origin. So let's suppose that the runner reached in the beginning to the 10 meters. So here we can draw an arrow from the origin to the 10 meters. This arrow indicates how far away an object is from the origin. Or let's suppose that the runner reached to 30 meters. So also we can draw an arrow and from the origin to the 30 meters, and that also indicates how far away an object is from the origin. The two arrows located the runner's position at two different times. So we can suppose that the runner started from here and she reached to 10 meters in a time. And after that, she continues her running until she reached to the 30 meters after another times. So, position is the distance and the direction from the origin to the object. The position, let's suppose that this is the first position for the runner. So, this is the distance and direction from the origin. We know now the distance is from the origin until this point is 10 meters, and the direction is to the right. Also we have here at a point which is 30 meters. So the distance is 30 meters from the origin, and the direction is to the left. So the position is the distance and direction from the origin to the object. Now we will learn vector and scalar in physics. What's the meaning of vectors and scalars? In the beginning, we will talk about vectors. So vectors is quantities that have both size, also we can say magnitude, and direction are called vectors. This is the definition of vectors. The quantities that have both size and direction are called vectors. Or we can say, instead of size, we can say magnitude, it's the same. So quantities that have both magnitude and direction are called vectors. Vectors can be represented by arrows. So the arrow here, we can say this is a vector, and also this is a vector. Position is an example of a vector. It's represented by the symbol x. So the first symbol that we will learn in this lesson, here we have x. X represented the position of the object. So suppose that here we have the first position, which is x initial, and here we have the final one, which is x final. X initial means the first position, and x final means the final position. Now we will talk about scalars. What does scalars mean in physics? A quantity that is just a number without any direction is a scalar. A quantity that is just a number without any direction, this is a scalar. The examples that we have about the scalars is time and distance, and the final one is temperature. What does that mean? That means if we have a quantity in physics without direction, so we called it scalar. For example, the time. If I ask you, what time is it now? Maybe you can say, for example, it's 3 o'clock. So you can say it's just 3 o'clock. You cannot say it's 3 o'clock to the left, or to the right, or to the north, or to the south. It doesn't make any sense. So also we have here, for example, the temperature. If I ask you, how's the weather for today? So you can say, for example, it's 10 degree. You cannot say 10 degree to the right or 10 degree to the left. So that's what we called it a scalar. Also we have here a distance. If I ask you what's the distance from your home to the school? For example, let's say it's 1 kilometer. So when you can say it's 1 kilometer from the school to the home, it's just a number without any direction. So that's what we called it also a scalar. Note that in general, distance is the entire length of an object's path, even if the object moves in many directions. This is a definition for a distance. So distance is the entire length of the object's path, even if the object moves in many directions. Here we have a homework question. Is a mass a scalar? And explain that. If you said yes, the mass is a scalar, so explain why this is a scalar. Or if you said no, a mass is a vector, also I need an explanation for your answer. The difference between two times is called a time interval. Time interval are scalars. As we said, the time also is a scalar. What's the meaning of time interval? The time interval is defined mathematically as follows. This is the equation for the time interval. The shape here, we called it delta. Delta is the Greek letter. It's used to represent a change in a quantity. So we have here delta t equal to t final minus t initial. That means the final time minus the first time. As you can see here, the runner is in the first position in 5 meters. She runs 5 meters just in 1 minute. And after that, when she reached to 25 meters, she reached this point also in 5 meters. So if we can calculate the delta t for the runner or the time interval for the runner, we can indicate that like this. delta t equal to t final minus t initial. So delta t equal to t final, this is the t final. The t final we have 5 minutes minus the t initial, here we have it, which is just 1 minute. So delta t equal to 5 minus 1, that's equal to 4 minutes. You can say here, see here that the delta t is equal to 4 minutes. We cannot say that 4 minutes to the right or to the left or to the north or to the south. The 4 minutes here without any direction, so that's what we called it a scalar. Until here, we reached to the end of our lesson. See you in the next one soon, inshallah.